2.5, lesson 2.5, solving equations involving absolute value. So some people get super tripped up on the idea of absolute value, but it really is simple. Don't let yourself overcomplicate it. Absolute value just takes whatever's inside, the value of whatever's inside the bars, makes it positive. That's it. So if we solved and the answer to this was -7, the absolute value bars would just make it +7. If we solved and the answer was +7, the absolute value bars don't do anything, right? Just makes the answer positive, that's it. So here, in this whole one side of the sheet, it just shows us what to do if it gives us a value for the variable and we have to plug it in and solve. So I'm going to zoom in here. It solves it for you in this example. Here it says evaluate the absolute value of t minus 5 and then -7 on the outside of the absolute value if t equals 3. So we start off here with our equation, and all it does is plug in a 3 in place of the t. That's it. So once we have this side right here, I'll highlight it so it's visually easier to follow. Once we have this, we plugged in 3 for t, then we just solve. So inside absolute value, you kind of treat them like parentheses, honestly. You have to evaluate what's inside of them. And once you get it down to one number, it can be a 2-digit number or whatever, but it's got to be one number. It can't have an operation symbol in it. Once you get it down to one number, then you can actually take the absolute value, meaning you can take the bars away and you can make whatever that number is inside the bars positive. So 3 minus 5 is obviously -2. So we have the absolute value of -2 minus 7, okay? So then we ask ourselves, all right, well then there's nothing else in here, just a -2. So what is the absolute value of -2? It's just +2. Whatever's in here, it's like little what do you call them? Like beam me up, Scotty, you know, like a little transporter. Just turns whatever's in here positive. That's it. So -2 becomes +2. And once we actually take the absolute value, like I said, the bars go away. So there's no bars here, but then we still have this -7 hanging off the end. And then 2 minus 7 equals -5. This part is not in absolute value. So it's okay that our answer is negative. That's fine. But the part that was in absolute value, we made positive. So that's all absolute value bars do. Okay, so we're going to do a couple of these and then focus on the other side of this worksheet, which is kind of a bigger deal. The substituting part isn't that difficult. All right, so here, evaluate each expression if, and then the only variable we have here is a t, and it says if t equals 3. So I'm going to say absolute value of 8 minus 3 plus 3, right? Well, 8 minus 3 is 5. So we have the absolute value of 5 plus 3. Now we only have one number in the bars, so now I can take the absolute value. The absolute value of 5 is just 5, right? That's it. So I have 5 plus 3, and when I add those together, I get 8. That's it. I'm done. It's like super easy, right? Number 2, also a t. So I've got the absolute value of 3 minus 3 minus 7. 3 minus 3 is 0, and you can't take the absolute value of 0 because it doesn't, I mean, I guess you can, but it's just 0. It's not positive or negative. So then we get 0 minus 7 equals -7. Okay, let's do one with a different variable here. R, it tells us up top, R is -2. So -2 plus, and then N is -3 minus 7. First thing I notice is that I got 2 signs touching here. I can't keep those 2 signs touching, so since they're different, I'm going to replace them with a minus sign. And -2 minus 3 is -5. So I've got the absolute value of -5 minus 7. So now since this is the only number in the absolute value, I can take the absolute value. So these bars turn whatever's in here into a positive number. So this becomes +5 minus 7. And 5 minus 7, of course, is -2. The answer to an equation with a bunch of stuff can be negative. That is fine. But if it's just absolute value, like if this was absolute value of r plus n equals blah, 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 then it has to be a positive answer. Okay? Down here at the bottom, let's do 2 of these and then flip over. All right, evaluate each expression if we have N, Q, R, V, W, and X. So we're just using whichever ones are problem has in them. Let's do 7 and 10. We'll just focus on those. Absolute value of 2 times q plus r. So 2 times q is negative 1.5, plus r, and r is where? Negative 3. And that's all inside absolute value. So 2 times negative 5 is negative 3. And then plus a negative, we have those two signs that are touching. I know there's a parentheses here, but there's no numbers in between our signs. So we consider them touching when there's no number that we're actually doing anything with. So plus minus becomes just minus. And negative 3 minus 3, if you're 3 feet down in a hole and then you go down 3 more, now you're negative 6, you're 6 feet down in a hole. And the absolute value of negative 6 is positive 6. And then number 10, we have v, which is negative 8, minus, and then the absolute value of 3 times n is 2, oh, there's the bell, plus x, and x is 4. So then we can, then we can simplify. 3 times 2 is 6, 6 plus 4 is 10, so I take the absolute value of 10, and the absolute value of 10, that's the only number I have now, so it's just 10. So this becomes negative 8 minus 10. And if you're 8 feet down in a hole and you go down 10 more feet, you end up at negative 18. So again, the final answer can be negative, but everything inside the actual absolute value bars becomes positive once you've simplified it all the way. Okay, let's do the back side. All right, I'll zoom out a little bit. All right, so here it says absolute value equations. When solving equations involving absolute value, there are 2 cases to consider. Okay, so we just want to kind of think of this level-headed, right? If absolute value bars make whatever's inside positive, then if we said that this problem equals 1, it really could have equaled negative 1, right? Because the absolute value of negative 1 is positive 1. Or it could have just equaled positive 1, and then you take the absolute value, and it's still positive 1. So it can equal a positive and negative answer. So whenever you're solving absolute value, usually, not every time, but usually you will have 2 answers, okay? If you have absolute value bars with nothing outside of them and they're equal to a negative number, that is not possible, and you would say no solution. Because if everything on one side of the equal sign is in absolute value, then the answer has to be positive. And so if it's equal to a negative number, it can't be. But in this case, it's not. So here, they solve this for us. Absolute value of x plus 4, there's nothing else outside of it, just everything's in the bars. Sorry. Equals 1, right? So we know x plus 4 might equal 1, or x plus 4 might be equal to negative 1. So we're going to write both of these equations out and solve both. So for all these problems we're about to do, that's what you're expected to do, is write out 2 problems, right? So we've got this guy, and we've got this guy. So we're going to get 2 different answers for x. If x plus 4 equals 1, then we have to subtract 4, and we end up with x equals negative 3. If x plus 4 equals negative 1, then we get x equals negative 5. We get 2 different answers here. X could be either one. If you plug either one of these back up here into the equation, if you plug in negative 3 plus 4 is 1. Absolute value of 1 is 1. If you plug negative 5 plus 4 is negative 1. Absolute value of negative 1 is also positive 1. There's 2 answers, and then when we graph them on a number line, you just put a dot. You draw your number line. You really only have to include the numbers right around your answer numbers. You don't have to like write out a number line with numbers 20 through, negative 20 or whatever. Just include a few tick marks, few numbers around your answers. Put a dot on each of your 2 answers, and you're done. Okay? So let's do a few of these. So here, number 1, we have y equals 3. So we can set y equal to 3 or y equal to negative 3, because the absolute value of 3 is 3 and the absolute value of negative 3 is 3. And then on my number line, I'm going to put a dot on negative 3 and a dot on positive 3. And that's it, I'm done. Easy peasy lemon squeezy, right? Okay, so here, x minus 4 equals 4. Well, we know that x minus, oh goodness, lovely bell. X minus 4 is either going to be equal to 4 or to negative 4. So we have to solve both of those possibilities. So if it's equal to positive 4, to solve, you take it out of absolute value. To solve, take it out of absolute value and set it equal to the answer. Take it out of absolute value and set it equal to the negative answer. There are no bars. When we're solving this and we write it out 2 times, that we've done away with the absolute value bars now. This is one choice, this is the other choice. Now we're just solving them straightforward. So here I'd add 4 to both sides, x equals 8. Here I would add 4 to both sides, negative 4 plus 4 is 0. So my 2 answer choices that would make this statement correct are 8 and 0. 8 minus 4 is 4, absolute value of 4 is 4. 0 minus 4 is negative 4, and the absolute value of negative 4 is also 4. So we have a 0, and we've got an 8. Done and done. So every single problem here has an equal sign, and you have to set what's inside absolute value equal to the answer and the negative answer of what's outside absolute value. Now, does it have... It doesn't. It might go into this later. Let me show you one. I don't know if you'll get to any of these on your homework, but I gotta think of it real quick to make up the numbers. But sometimes we could have, like, let's say 2x minus 4 absolute value plus 5 equals, let's say, equals 5, right? Something like that. Well, what do I do if I have a number outside absolute value and I'm trying to solve? You want to get rid of everything outside absolute value. You don't want anything left. You don't want anything outside absolute value. So I need to get rid of this 5. These go away. Absolute value of 2x minus 4 equals 0. Now, this would be a case of you only get one answer here because we would set 2x minus 4 equal to 0, and then if you set 2x minus 4 equal to negative 0, it's the same thing, right? You can't really set it equal to negative 0. So here you would solve, and you would just get one answer for x. 2x equals 4, x equals 2. And it would be the same here because there's really no such thing as negative 0. So you would get one answer, x equals x equals 2, and then you would put a dot on 2 on your number line. 0, 1, 2, 3. And you'd put a dot here and be done with it. That's what your answer would look like, right? Let's try another one. Let's do, I gotta think of it off the top of my head. If I had the absolute value of, let's do this, okay. Absolute value of 3x plus 4 equals 17. Oh, shoot, I don't want to do that. Well, absolute value of 3x plus 4 minus 6 equals 11. Let's do it that way, yeah. So if we had a problem like this, okay, we can't just take this whole thing and set it equal to 11 and negative 11 because we just want to take what's inside absolute value and set it equal to the answer and the negative answer. If there's stuff outside absolute value, it messes everything up. So we need to get rid of everything outside absolute value. So first I want to add 6 on both sides of my equal sign, right? So now I am just left with the absolute value of 3x plus 4 equals 17. Now I can set 3x plus 4 equal to 17. And 3x plus 4 equal to negative 17. These are my 2 equations I'd have to solve. So here I subtract 4. 3x equals 13. I didn't know that was going to work out that one. That's okay. It's supposed to be 18. That's all right. So So here I would just say that x equals, I could either leave it as 13 over 3, or I could say that it is 4 1/3. Okay, and then over here, minus 4 minus 4, 3x equals negative 21, divided by 3, x equals negative 7. So here I would have two answers, right? Either one of these answers would make my original equation up here, this guy, correct. 4 1/3 or negative 7. So the whole idea is when you're solving for absolute value, take what's inside absolute value, take it out, take this whole thing outside of absolute value, set it equal to the answer and the negative answer. So we did 3x plus 4 equals 17, and 3x plus 4 equals negative 17, and solve both of those. Take it out of absolute value and then solve, okay? If there's other stuff around absolute value, get rid of it. All you want left before you can solve is what's inside absolute value bars. Then you can take that whole side out and set it equal to the answer and the negative answer. Okay, and the last little part I wanted to go over with you is up here at the top of the study guide. If you printed it out, you'll see it up at the top. But it is looking at the graph of absolute value and writing your own equation. So in order to do that, so we have a graph here, a number line, that's the graph of absolute value. These are our two answers to whatever absolute value equation exists, right? One answer is negative 2, one answer is 4. So how do I write an equation where these are my two answers and the equation has absolute value? Okay, first thing you want to do is find the midpoint between negative 2 and 4. One point that's equal distance. It's right in the center of these two numbers. So first thing you're going to do is add them together and divide by 2. So 4 plus negative 2 divided by 2 is 2 divided by 2, which is 1. So the point that's equal measure between negative 2 and positive 4 is 1, right here in the middle. So our question then becomes, what's the distance from negative 2 to 1? And it should be the same from 1 to 4. What's the distance, right? The distance looks like it's 3 units. 1, 2, 3. 1, 2, 3. So when we write our equation, and it shows you down here, but I'll show you too. When we write our equation, we're going to say that the distance from our number, which is our two answers up here, these two dots on our graph, whatever that number is, the distance from that number to 1, and remember distance means difference. When you're finding the distance between 2 points, you always subtract the bigger number minus the smallest. So the distance on a number line between our answer, we've got 2 of them, and the number 1 equals 3 units. So equals the number of units, right? So again, here we're going to say, we'll say this number is midpoint. That's the midpoint of our two answers that it will give us for any problem when we solve it down below. So x minus whatever the midpoint is equals the distance between two answers. Okay, so this is how we're going to set it up when we're looking at a graph. So x minus a number, which is the midpoint between our answers. Our answers are negative 2 and 4. We determine the midpoint is 1. So x minus the midpoint, x minus 1, equals whatever the distance is from our two numbers to 1. So from negative 2, it's 3 units. From positive 4, it's 3 units. So the distance from our answer to 1 is 3 units. Okay, so let's do a couple down here. There's 3 at the bottom. I put an arrow here. First off, our numbers are negative 4 and positive 4. We have dots on them, right? So I know that the midpoint is 0. You can add together and divide by 2, but the midpoint's going to be 0. So we're going to say the distance between minus our numbers and the midpoint, which is 0, that's what goes here, equals how many units? How many units is it from 0 to negative 4? I know that looks like 2 here, but it looks like each tick mark here is representing 2 units. So from 0 to 4, it's 2 units. From 0 to negative 4, from 0 to 4, it's 4 units. and 0 to negative 4, it's 4 units. So we're going to write x minus 0 equals 4. And then can we simplify that? Yeah, I don't have to leave it x minus 0, so I'm just going to put x equals 4. So once I get my final answer, this is my equation that represents this graph, or this graph represents this, make sure it works. If I put negative 4 in for x, does the absolute value of negative 4 equal positive 4? Yes, it does. What about positive 4? Is the absolute value of positive 4 equal to 4? Yes, it works. So that's all we're doing. So let's do number 14 here. So our two answers are negative 1 and positive 3. So I want to find their midpoint, right? Negative 1 plus 3 is 2. 2 divided by 2 is 1. So here's our midpoint. I always draw a little arrow above it so I don't forget what it is. There's my midpoint. So the distance between my solutions and the number 1, the midpoint, equals how many units? So if I go from 1 to negative 1, that's 2 units. 1 to 3, that's 2 units. So equals 2 units. Can I simplify this at all? No. So this is my equation, my absolute value equation represented by this graph. If I tried this, would it work? If I put negative 1 in for x, negative 1 minus 1 is negative 2, and the absolute value of negative 2 is positive 2, so that works. What if x was 3? 3 minus 1 equals 2, and the absolute value of 2 is 2. So yes, that works. So once again, here's my graph. My two endpoints are negative 7 and positive 1. So first I want to find the midpoint, right? So negative 7 plus 1 divided by 2, that's negative 6 divided by 2, which is negative 3. So my midpoint is negative 3. So I write the distance between my number, minus difference means distance, minus, anytime you're talking about distance, you're using a minus sign. The distance between my number and the midpoint, which is negative 3, equals how many units? Well, here's negative 3, so it's 1, 2, 3, 4 units this way, and 1, 2, 3, 4 units this way. Okay, can I simplify this at all? Well, yeah, a double minus sign equals a plus sign, right? So x plus 3 in absolute value equals 4. This is our equation of this guy. So you're always using this thing up here, the difference between x, which is the dots that are already on the graph, our numbers, there's 2 of them, the distance between x and the midpoint between those two x's equals the distance, okay, I guess distance over here. Okay, so x minus the midpoint between the two x's equals the distance that it is from each x and that midpoint. I feel like we need to do a couple more of these. Let's do it. Let me draw some on the back. Okay, so if I had a number line, and let's say I had 1, 2, 3, 4, 5. Let's put another one, 6 here, and let's do negative 5, negative 4, negative 3, negative 2, negative 1, 0. And let's say my two answers are 0 and 4. Okay, so here's my graph. That wasn't a very good representation. So these are my two things here. Now I have to write an equation in absolute value form that this graph represents, right? So first thing I want to do is find the midpoint, the exact middle between negative 4 and 0. That's negative 2, right? Just add them together, divide by 2. Negative 4 plus 0 divided by 2 is negative 2. The distance from negative 2 to negative 4 is 2 units. 2 units. The distance from negative 2 to 0 is 2 units. So when I write my equation, I write x minus whatever the midpoint is, here it's negative 2, equals whatever the distance is from our points to negative 2. Here it's 2 units. And then if I can simplify, I need to do it. This becomes a plus. X plus 2 in absolute value equals 2. Let's do another one. Let's do it if it's positive. Let's do 1, 2, 3, 4. 3, 4, 5, 6, 7, 8, 9, 10. Here's our graph. We have to write an absolute value equation that this graph represents. So first I want to find the midpoint between 4 and 10. That's going to be 7, I believe. If I add 4 plus 10, that's 14. 14 divided by 2 is 7. So here's my midpoint. So I'm going to say x minus 7 equals, and then what's the distance from 7 to each of those, right? This way it's 3 units. This way it's 3 units. It's always going to be the same on both sides. So the distance equals 3. I hope this is making sense the more we do it. One more, you can turn it off now if you're done. We'll do one more. Okay, number line. I'll try and make them like super far apart. We'll do them with big numbers too. All right, I'll do a dot here. And a dot here. And we'll do 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and then that last one down there is 22. Okay, so here's our number line. So we've got numbers at 13 and 21. So what's the midpoint between 13 and 21? If we add 13 and 21 together, we get 34. And the midpoint, if you divide 34 by 2, you get 17. So we'd write x minus 17 in absolute value. The distance between our solution and the number 17 on a number line equals how many units? So to get from 17 to here, it's 1, 2, 3, 4 units. 17 to here is 1, 2, 3, 4 units. So this would be my equation, okay? Let me know if you have questions with that, because you will have some problems where you have to write that out on your practice sheet. You have to, or your skills practice sheet you have to do. I don't remember if this one's practice or skills. One or the other. You'll have some like this. Okay? Let me know if you have questions. Thanks.